All right, we are going to continue on in Unit 8 looking at this idea called mathematical induction. So hopefully you've had a chance to watch that introduction video posted on Schoology. It's got to do with the dominoes. That's kind of a classic way to think about induction, how the first term, if it's true, it falls down. It then knocks over the second term, which goes to the third term. And so you can end up proving that everything is true. So again, one of the key points in induction is that you have to have your starting point. So you got to know what that first term is, and that first term has to be true. Then your goal is to prove that the next term is true. And then if the first term is true, which is the next term is true, if you continue along that path, then everything is going to be true. So kind of like what we do or what we think about this to prove it is we take our next term and we sub it in for P of K. So find P of K for each PK. So again, what that means is that I'm looking for like the induction. I'm going to say, all right, if I have this form right here, K squared, K plus 1, this is like what I'm starting with. And then what I'm going to do is I'm going to say every time I see a K, I'm going to plug in a K plus 1. So we're going to rewrite this as saying PK plus 1 is 2SK plus 1. So every time I see a K, instead of writing K, I'm going to write K plus 1 squared. And then this one has K plus 1, but I still have a plus 1 on the outside, and my denominator is not going to change because there's no K's. So now I can start simplifying, and I would say, hey, this is actually like saying K plus 1 squared equals K plus 1 equals 2. Oh, wait, that's not an equal sign, excuse me. All right, those are together, and then it's over 4. So we have successfully kind of introduced our original statement where we said, hey, we just had K, now we have K plus 1, and then where we had K plus 1, we now have K plus 2. Therefore, as we continue down this path, we are going to keep knocking over our dominoes and being able to simplify. Let's do another example. Let's say that we have something like, okay, we've got, and it's going to go 1 plus 5 plus 9 plus, and it's going to go all the way to 4K minus 1 minus 3 plus 4K minus 3. And again, how do I go about solving this? I'm going to need to plug in K plus 1. So every time that I saw a K, I'm going to, instead of writing a K, I'm going to write K plus 1. So it starts off the same. Again, 1 plus 5 plus 9. But now I'm getting into 4. So now I see a K. So now I'm going to write K plus 1. In parentheses. And then minus 1. Well, and then we have to include that minus 3 as well. My parentheses got a little mixed up, but it's still going to work out just fine. And then this time we have 4. And then this time it's K plus 1 minus 3. So as I simplify, again, 1 plus 5 plus 9 plus, this is going to be 4K plus 4 minus 1. Or it's going to be 4K plus 1 minus 1. So I end up simplifying this to 4K minus 3. And then this is going to be 4K plus 4 minus 3, 4K minus 1, or plus 1. So again, if I compare where I started, and I started with right here. Again, instead of having k minus 1, I just had k. And then when I look at what I had over here, 4k minus 3, I have 4k plus 1. That is, you know, a difference of 4, which shows me that I found the next term. So those are just like preliminary examples, just like looking kind of ahead. That's not using it. That's not proving it. That's just, again, like the dominoes idea, talking about how something like this works, which eventually leads us to kind of our formula, or our summation formula. And it's helpful to think about things as the next term. So again, the next term is going to equal the previous term, the one less term, plus a of k minus 1, and then again a sub k plus 1 equals, or it is the k plus 1 term. So again, this kind of helps us get a sort of a summation formula. So now we're going to actually use it. So this was, again, more just kind of talking about it, saying what mathematical induction is. Now we've kind of developed this idea where to get the next term, we take our previous term and then add, this is a plus, excuse me, a k plus 1. So a k plus 1 is the k plus 1 term, or original sum. All right, so let's do an example. Using mathematical induction. Okay, so let's take the formula 1 plus 3 plus 5 plus 7 plus 2n minus 1 equals n squared. So we got to prove that this is true when n equals 1. So again, if we go all the way back to the first thing we talked about, you have to have a starting point. So this is going to be my starting point. P of 1 is true. So we have to first prove that P of 1 is true. This first term's true. If this first term isn't true, we can't use mathematical induction. Like, the proof is over. So, well, this one's, I guess, relatively easy to plug in because, hey, if we try it out, s of 1 equals 1, which is the same thing as 1 squared. 1 times 1 is 1. So, yes, that checks out. We're good. The second part of mathematical induction has 2 steps. The first step is to assume the formula is valid. So, again, we always assume it's true, and we try to prove that it is. For some integer k, the second step is to use this assumption to prove that k plus 1, the next term, is true. So again, maybe we label it, this was step 1, here's step 2. So we're going to, again, assuming that this is true right here. So assuming that this is true, I'm just going to copy it. Now we have to show that, oh, and it's a goofy thing, but when we talk about it, it says S sub n, and then when we start to get in to prove it, we switch over to k's. That's just, it's something that you do. Again, I'm not going to dock you points if you use k's instead of n's. It's just one of those goofy math things. So as we work through this, again, this is a K, maybe we'll do a different color. K. All right. So now we're going through and we say, well, now I want to prove k plus 1. I want the next term. So again, I still am going to have 1 plus 3 plus 5 plus 7. But now I'm going to have 2k minus 1 plus 2k plus 1 minus 1 over here. So as we go through, and again, where did I basically swapped out right here instead of I added a +1 in there. So 2k plus 1 minus 1. As we go through and simplify, this stays the same. This term is still the same. Now I have 2k plus 2 minus 1, which we'll put in parentheses or brackets. Again, I can simplify certain parts of this. So really, if we look here, all of this is exactly the same. So I'm just going to go ahead and call that SK. And then what is different is this part, 2k plus 2 minus 1. And I can simplify 2k plus 2 minus 1 to just be plus 2k plus 1. So again, we already said that, hey, this whole thing equaled right here. We said that SK equals k squared. So I'm going to plug in something for SK, which we said is equal to k squared. So k squared plus 2k plus 1 equals, when we factor it out, what multiplies to add to get 2, but equals 1. Okay, we get, it adds to get 2, but it multiplies to get 1. We get k plus 1 squared, which if we think all the way back to it, that was what we were trying to prove all along. We wanted to prove that the next term equals and has the same ratio as up here. So we did it. We used mathematical induction to prove that this is true. So part 2 is true as well. There is a lot that goes into it. I get this. This is a difficult topic. I remember, obviously, as a math teacher, I took a lot of math classes, and I think we talked about some form of mathematical induction in almost all of them. So again, as you continue on in your math career, this is a topic that you will continue to see. Okay, it's kind of the basis of some ideas, like some core ideas in math and calculus and those things moving forward.